In this video, I will explain parameter passing methods. Like there are three parameter passing methods: pass by value, pass by address, and pass by reference. So for explaining all three, I have taken one simple example, that is swapping of two numbers. I have a function for swap. So let us understand all these three methods. So first is pass by value or call by value. This example is based on call by value. Let me explain you the example first of all. So this is the main function having variables a and b with values 10 and 20. So these are the variables of main function having values 10 and 20. Then it is calling swap function. Swap function. This swap function is taking two parameters x and y, and it is swapping the numbers x and y with the help of a temporary variable. And then when the control come back to the main function, it will print the values of a and b. So this is the code main function and swap function. So here in the diagram, I am showing the variables of main function a and b, and these are the variables of swap function, that is x, y, and temp. And inside the main memory, this is the code section where our program is residing, and these are the stack frames or the activation records of main function and swap function. When the function swap is called, this activation record will be created and deleted when the function ends. So for explaining the working, I have taken these diagrams. Now let us understand call by value and understand its working. Now call by value. See here, the main function is passing these parameters. These are actual parameters, and these are formal parameters x and y. What happens when the function is called? The value of a and value of b. A is copied in x and b is copied in y. So 10 is copied here and 20 is copied here. So the formal parameters are normal variables. So they will take the value of these parameters. They will take the value, right, when the function is called. Now this function, as I am not returning anything, it is void type. Now this is the logic for swapping the values. X and y are swapped, so with the help of temp. So first line temp assign x, so this will become 10, and then x assign y, so this will become 20, and then y assign temp, so this will become 10. You can see that the formal parameters are modified, but actual parameters remains same. So the swapping is done inside the variables of swap function only. They are not reflected inside actual parameters. So when the function ends after this line, when it comes back here, there is nothing written, it is void type, then print. So a and b are printed. So what are the values still? 10 and 20. So these values are not swapped. These values are not swapped. So I'll get the same values, 10 and 20. So if you see here, these 10 and 20 were there, and these 10 and 20 were passed, and with the help of temp, this became 20 and this became 10. But actual parameters, they are same only. So this is pass by value. In pass by value, any changes done to formal parameters will not reflect in actual parameters. So when you should use pass by value? When you don't have to modify actual parameters, you can use pass by value. And you can use pass by value if a function is returning some results. So swap function should not be written using pass by value. In the previous video, we saw adding two numbers, so that is suitable for pass by value. So pass by value can be used there. But here, pass by value is not suitable for swapping two numbers. So anyway, we have learned what is pass by value. So in pass by value, actual parameters will not be modified if any changes are done to formal parameters. Next, I will show you call by address. Now let us look at call by address. So in call by address mechanism, the addresses of actual parameters are passed to formal parameters, and formal parameters must be pointers. Any changes done inside a function will modify actual parameters. Now here we have to learn two things: how to write call by address and how it works. So remember, call by address uses pointers. So let me write down the syntax. So you have to observe the syntax very carefully. This code is same as call by value code, right? Now how to convert it into call by address code? So what are the things I have to do? So here inside the main function, when I'm passing these parameters, these are actual parameters, so I should send there addresses. So these are the addresses. So the first thing. So it means I am sending 200 and 202. Now who can take addresses? We know pointers can take addresses. So these must be pointers. Yes, these are the pointers, right? So it means when I pass from here the addresses, 200 will be copied in this one and 202 will be copied in this one. So when the function is called. So it means this is pointing on this and this is pointing on this one. Yes, those are the pointers. Now here inside the code, as this is a pointer, if I say just x, it's 200. So this will be 200. No, I am talking about this, the value here, that is 10 and 20. So I am talking about the value. So here I should say asterisk and asterisk x, asterisk y, and here also asterisk. So these are the changes we have to make. So first I wrote a simple code of call by value, then I made it as call by address. So in call by address, the formal parameters must be pointers, and here I have to use dereferencing, that is asterisk, for accessing the data of actual parameters. And here addresses must be passed. So these are the changes in the syntax. So you should observe the syntax very carefully. Now I will show you the working. Let us start and executing the program. See, first the main function is having two variables a and b. They are having value 10 and 20. So these are 10 and 20. Next, the swap function is called. The addresses are passed. So these are the pointers, so they will take the addresses. So here in the diagram, if you want to see, these are pointing on this one. They are having their addresses. So now this function can access the variables of another function. It's not directly, it is indirectly using pointers. Yes, one function cannot access the variables of another function directly, but it can access using pointers. So it can access indirectly. Yes, this is indirect access. Now, when the function is called temp is already there. Temp assigns star x. So star x, asterisk x, so that is 10. If you say x, it is 200. Asterisk s, it's 10. So 10 is stored in temp. Asterisk x assign asterisk y. Asterisk x 10, asterisk y 20. So this is copied here. 20 is copied here. Then asterisk y assign temp. Asterisk y is this one, assign 10. So temp is 10. So it is 10. Now you can see that actual variables are modified. So when the function ends, a control come back, and when it prints, the value of a is 20 and the value of b is 10. So this is 20 and this is 10. So yes, these are swapped. So call by address is suitable mechanism for modifying the actual parameters. So we will be using this type of code more frequently in our programs. So you should be familiar with this one. Call by address is more useful. So that's all about call by address. Now the last thing is call by reference. Now let us see call by reference. For call by reference, I have written back the same example. Now this is call by value parameter passing method. Now what are the changes in this I should do so it becomes call by reference? So what is a reference? Already we have learned in the previous video, and references are supported only in C++, right? This is not a part of C language. And this is a very useful and powerful mechanism or feature of C++. So here you have to learn two things: how to write call by reference and how it works. So first of all, how to write call by reference. Let us look at the code. Here inside the main function, I have two variables a and b are passed. So this is call by value, right? Nothing is written here. There's not ampersand or anything. This is call by value. And here these are also normal variables. So this is call by value. And this is normal code. So same as call by value. How to make it call by reference? Let us see the changes. Here in actual parameters, don't do anything. Don't do anything. And inside the body, don't do anything. Same as call by value. Only in the parameters, just before a parameter name, variable name, write ampersand. So simple syntax. Syntax is very simple. Just write ampersand there. Those are references. This is a reference to A, this is a reference to B. Y is a reference to B. Those have become references. And how do you use references? Normally like other variables, normal variables. So normal variables, those are normal variables. So syntactically, this is call by reference. See, it's not a major change. Compared to call by value, it is similar, just we are having ampersand there. Now, working, how it works. See this. Let us start. Program starts from main function. A and B are two variables, okay? Then A is having value 10, B is having value 20, A is having value 10, B is having value 20. Swap function is called by passing A and B. A and B are passed to X and Y. X becomes a reference to A, Y becomes a reference to Y. Reference is nothing but alias or another name or a nickname to a variable. So this itself is X and that itself is Y. So does it take any memory? References doesn't take any memory. Existing variable, another name is given. Yes, so that doesn't take any extra memory. So these 4 bytes, 2 bytes for integer, 2 bytes for integer, same 2 bytes. So these 2 bytes are called as X and that's 2 bytes are called as Y. See, these variables actually belong to main function. Main is calling them as AB and swap function is calling them as XY. Yes. So swap is calling with another name. Now let us continue. Temp variable is declared. Okay, temp is also declared. Temp is also declared. Then temp assign X. So X value is stored in temp. Then X assign Y. So this becomes 20. Then Y assign temp. So Y becomes 10. Function ends. Control come back to this line. Print what are A and B? 20 and 10. So 20 and 10. So you can see that when these formal parameters X and Y are manipulated, the actual parameters are modified. So that's it. This is called by reference. Now one important point. I said that one function cannot access the variables of another function directly. It can access indirectly. But how it is possible that it is accessing directly? So the answer to this is, if you see inside the memory, swap is not a separate function. Swap is not a separate function. It has become a part of main function and there is only one activation record. So if you see the working of the same program here, now as long as the main function code is running, these are A and B. And once the swap starts, these are called as X and Y. And also temp variable is created inside same code activation record of main function, right? Inside the same stack frame. And once the main swap function ends, this is gone and the values that were 10 and 20, these are changed to 20 and 10. So this swap is not a separate body of a function. It has become a part of main function. So it means the machine code of this swap function will be pasted here. So this is more like monolithic program, right? The entire code inside single main function only. So the machine code is monolithic, though the source code is procedural or modular. So yes, C++ does this one. C doesn't do this. C++ allow call by reference and the code of that function will be copied at the place of function call. So do you think this should be allowed or this we should entertain that code is copied there? So what is the use of writing function? So yes, this is not advisable to use call by reference more frequently. You can use call by reference for small function, 1 or 2 lines of function or the function like the swap. You can use call by reference, but don't use it for heavy functions which are having loops and all, having complex logic. So call by reference should be used carefully. So it's a more powerful feature of C++, but it should be used carefully, right? It cannot be used always. So that is the reason C++ also have call by address. So more commonly used features are call by value and call by address, right? So that's all about parameter passing methods. Then in the coming videos, I'll show you how to pass arrays to the function and how to pass structures to a function.